Like pH 79 for pH 80, I'm going to just focus on the Vesper and IMA questions. So the first one is just a review. So just remember, number of things. I like using things versus bonds because things could account for both bonds and lone pairs. So how many number of things around the atom, or the one that we care about? So if it's 2, then we have 3, and then we have 4. If it's 2, it's going to be bent. So here is carbon dioxide. It does not have any lone pairs, so it has 1, 2 things attached, so it's going to be linear, and the bond angle is going to be 180 degrees. When it's 3, like SO3, you have 1, 2, 3 things attached to it. I'm going to undo it so it won't get too confusing. So you have 3 things attached to it, and in that case it's going to be trigonal, planar, and the angle right here is going to be 120 degrees. Okay, so in pH 79 we had SO2, and this still has 1, 2, 3. It's still a trigonal planar, but you just don't see that one, so you could also call it bent. But this bent is a little bit different from a water bent because it's at 120 degrees. So don't make the mistake I did. And then for the last one, let me pick a color I haven't used, green, is a tetrahedral, so 4 things attached. So here is my CH4. And when you have 4, that means it's trigonal planar. Whoops. Trigonal planar. And that is 109.5 degrees. And this is if you have 4 things. Now if you have a lone pair, so if one of them was a lone pair, so let me try to think, NH3. Then this is a pyramidal. Let me check. How do you spell it? Can never spell it correctly. I don't have it. Oh well. Midal? I think this is a but anyway, whatever. The lone pair is going to push these bonds a little bit more, so it's going to be 107 degrees. And then the last one is water, where you have 2 lone pairs, and that's going to push those bonds right here even further. And this one's bent, and it'll be 104.5. So here's all the different variations that you're going to see. I really just want you to know 2 things linear, 3 things trigonal planar, 4 things a version of tetrahedral. Did I write trigonal planar? Why did I write trigonal planar? Sorry, I meant to say tetrahedral. I don't want to redo it. Sorry, tetrahedral. All right. So there we go. Luckily I caught it. So you have tetrahedral, trigonal planar, which is up there, etc. So that would be the review question number 1. That's just the opening from your textbook. So we're going to compare HI, HF, and then HBr. So we know that this is the most electronegative, and it could also make hydrogen bonds. These are also dipoles because you have a very electronegative bromine or a very electronegative iodine. So we want to make sure we find out which one's which. This one's going to have the strongest bond. Okay. And this one has a higher mass. So when you think about it, if it has a bigger mass, that means it has more protons and more electrons to move around. So then its dipole will be a little bit stronger. Hydrogen bond we already know is strongest. So this will be the second strongest. So the thing with the lowest boiling point would be HBr. Then it's going to be HI, and then finally HF. Okay, so HBr is going to have the lowest one because it has, even though it's same with HI, since this has a higher mass, this is going to be the lowest, or out of these three, the weakest. Out of these three, if we're just comparing these three. All right, on part B, we have SO3, which I kind of drew already. If you want, you could do SNA. So we have 1, 2, 3, 4. 4 times 8. I could do this. 32. And then each of these have 6. So 4 times 6, 24. And 8. So they're going to have 8 shared electrons or 4 bonds. And that's what we have right here. So here we have 1, 2, 3 things. So this is going to be trigonal, planar, with a 120-degree angle. Oh yeah, and then we need to do IMA. So here, they're all gonna pull towards the middle. Oh, sorry, pull out. They're all gonna be pulling out because oxygen is more electronegative, so they cancel each other out. The next one is PCl3. So you could do SNA if you want, but this is the shape that's going to be a pyramidal? Yeah. I can't spell it, I'm sorry. So that means the bond angles will be 107 degrees. And this one is polar because chlorine is more electronegative. I'm not looking at a periodic table, so I'm pretty sure it is. So that means you have a net dipole down. So this is going to be partial negative, partial positive, if I remember my electronegativity is correct. All right, so that's that one. Letter E, it says the bond angle of water. This is a bent, but you have 2 lone pairs, so technically it's a version of tetrahedral. But you don't see the lone pairs, so it's going to be bent, and the bond angle is 104.5. And NH3, you have also a tetrahedral, but instead of 2 lone pairs is 1, so it's a pyramidal, and it's going to be 107 degrees. Okay, so that's that one right there. Let me make sure I get this one. Let's see. And the last one, HCl, CF4, SIF4. So let's see, this one is going to be linear. This one is going to be tetrahedral. This one is also going to be tetrahedral. And so that means this is 109, 109.5, and then this one's going to be linear, so it's 180. Let's see, what are the questions? So when you're looking at this, you want to see which one boils. So let's see. So my son answered my phone, so give me a second, help him out. All right, so those are the shapes. Now let's look at the forces that are act in between them. Here you have hydrogen with chlorine. This is going to be very, very much more electronegative. So let's pull this way. So we're going to have a dipole. So even though these are all going to be tetrahedrals, and individually they do have dipole movements, but they do cancel each other out. So this is a net of 0, and this one also has a net of 0 because they're all pulling in opposite directions. So these are both London dispersion. So the one with the strongest intermolecular forces is going to be this one. So this will be the strongest. And then you're going to look at these two. Which one is bigger? Silicone's bigger, so this will be the middle, and then this will be the least. So if we're looking at boiling point, the strongest is going to win, and then middle and least. So what do I want you to know for tomorrow? Boiling point is just asking you which one's going to be the strongest. So even though you don't know, you should be able to tell, okay, which one's the strongest. So hydrogen bond is the strongest, then dipole, and then finally London dispersion. If they're both the same, then you're looking for the one with the most mass. So that's kind of the key right there. I think I hit on all the topics. Email me if you have any questions, and I'll try to get back to you. Good luck.